Hey everybody, it's another ChatLoopBackOff, and today we have Swastik. We're going to talk about CubeFS, so take it away.
Hi everyone, my name is Swastik Gour. I am a product engineer at Cloud Technologies, and I am also an CNCF ambassador and an active open source contributor. And today we are going to deep dive in a project that is a CNCF graduate project called CubeFS. Together hopefully we will learn a lot of things about CubeFS and its interesting use cases and uh, I would like you to follow along with that, and hopefully we will be learning a lot about this CNCF graduate project, and that is made by JD.com, which is China's largest e-commerce platform. So the best way to learn about any new project or uh, uh, learning about any new project or using it is just hopping onto its documentation. So here I have already uh, opened the documentation and I am currently in its homepage. Uh, Here it says CubeFS is a cloud native unstructured data storage. So like its name suggests, uh, it is an uh, it is a file system storage solution that is specific to cloud native, and it's compatible with cloud native technology, specifically to Kubernetes. And it says here KubeFS is a new generation cloud native open source storage system that supports access protocols such as S3, HDFS, and POSIX. So it's compatible with S3, which is the storage system that is provided by AWS, and HDFS, and it's also compatible with POSIX. So, and it's also widely used in big data, AI, ML, and LLMs. So yeah, it has it has a lot of interesting use cases. So key features of QFS are it supports multi-protocols such as S3, POSIX, and HDFS. It's multi-engine, so supports replicas and erasure coding engines. Okay, so basically it supports high availability. That's interesting. Easy to build a PV or PV scale or distributed system storage. So it's highly scalable, horizontally scalable, uh, and it's multi-talent. So basically that means uh, so different group of people can with different roles can access it, uh, and it has high performance, supports multi-level caching, multi high performance replication protocols, and optimization specific performance for small files. Okay, cloud native, easy to use CubeFS in Kubernetes. Oh, it has a CSI driver interface as well. So okay, so I guess uh, they provide their own CSI drivers so that we can just use it in a storage class, and then we can use it in a PVC and mount it in a pod that we want we want to use. Okay, so that's quite interesting. CubeFS has a developed CSI plugin based on the container storage interface. Okay, uh, so basically, container storage interface is basically standard that is defined that defines how our storage solution should be, and how it should be compatible with Kubernetes and cloud native infrastructure. So and it has CSI plugin. That means you can use a storage class. So storage class is basically just a template which defines how what storage type we are using. So we can actually use like S3 or HDFS as a storage class as well, and mount and use then mount it using a PVC. Interface specifications to support cloud storage and Kubernetes cluster. Okay. CubeFS application scenarios. Okay. These are all the blogs and interesting use cases. So before that, I would like to go through its basic documentation so that we can actually have an idea of what it actually is, how it internally functions, uh, and how we can actually set it up. So we have actually gone through this. CubeFS is next generation storage product, and it is a graduated open source project under CNCF. So okay, uh, since it is a graduated project, it must have been widely used by a lot of MNCs and must have a lot of feature and use cases. It is compatible with various data access protocols such as S3 and okay, multi-replica, okay, multi-protocol, multi-engine, okay, high performance, metadata management, okay, that's something new. The metadata clusters uses in-memory metadata storages and uses, okay, this uses B minus tree and B plus tree. So basically, uh, B minus tree or B plus tree are data structures that are used for fast caching of your data. In this case, we are actually storing our metadata using B minus and B plus tree. Uh, storage, strong consistency replication protocol. This is something new. Uh, CubeFS adopts different replication protocols according to the write mode to ensure data consistency between, okay, basically it maintains consistency between application and multi-level caching. Uh, what's erasure encoding actually? Okay, let's just search for it. Okay, it is a data protection technique that breaks data into fragments and generates redundant parity information. Okay, so it is kind of an encoding technique for the data to be protected. Okay, got it. Azure encoding volume supports multi-level caching acceleration capability to provide higher data access performance for hot data. Okay. Uh, block cache component can be deployed. Okay. A distributed global cache build using the replica component data node, for example, a data node with an SSD. Okay, got it. And these are all the application scenarios. Okay, as a cloud native distributed storage platform, CubeFS provides multi-access. Yeah, we know that. Compatibility with HDFS protocols, CubeFS provides a unified storage foundation. Okay, deep learning and machine learning as a distributed parallel file system. Okay. So basically, parallel file systems are the ones which support parallel metadata operations, basically simultaneously read and write, which can be really useful while a machine learning training because it involves a lot of computation. So I can see why it is used in machine learning and deep learning approaches. Container shared storage. Uh, okay, so basically it's really shardable file system. Database and middleware provides like high accuracy and low latency. Okay, Online service, okay, low cost services for online business. Okay, lower this is lower in cost. That is also a great thing. So far so good. Let's jump into its architecture. That is what I'm really interested in. Okay, I would always recommend like skip the diagram first and read uh, the description because this thing really confuses me when I see any diagram of an architecture. CubeFS consists of a metadata system, a data subsystem, a resource management node, master node. Okay, so it is a master uh, slave architecture that Kubernetes uses as well, and an object gateway, object subsystem, which can access stored data through POSIX, HDFS, and S3 interface. Okay. Uh, Resource management node composed of multiple master clusters, master nodes. It is responsible for asynchronous processing on different type of tasks. Okay, such as managing data shards and metadata shards. So okay, it is responsible for asynchronous communication of tasks between different nodes. Metadata subsystem composed of multiple metadata nodes, multiple metadata shards, metadata partitions. Okay, so if you don't know, metadata is just like a log of such as name of a file system or uh, checking in, check out of checking in, check out of a file. So uh, it is basically you can consider it as a metadata that we have in Kubernetes as well, and raft instance based on multi-raft replication protocol. Okay, it supports raft replication protocol as well. Each metadata shard represents an inode range metadata. Okay, which contains in memory b minus 3 and b plus 3. Okay, like we saw earlier. Data subsystem divided into replica subset. So this is divided into multiple replica subsets, which uh, has erasure encoding for our data, and uh, this is the main part that actually stores our data in blob storage format, if I'm not wrong. Yeah, data subsystem is the one. So yeah, here are data nodes, data partition, erasure encoding. Uh, so here is the client. Okay. Master node basically handles communication, asynchronous sharing of the files between sharing of information between all of the subsystems, including POSIX HDFS interface, metadata subsystem, and data subsystem. And we have an object subsystem, which composed of object nodes. It provides an access protocol. Of, it provides basically an access protocol compatibility with S3 and HDFS and POSIX. Okay. Volume, a logical concept composed of multiple metadata and data shards. Okay. Now we have an idea about its structure. So basically, it has a data node, a metadata node, and a master node. And I believe all of these things are actually, apart from object subsystem, are from the client side. Okay, let's jump into quick start. Uh, I believe after just learning a bit about uh, architecture of our architecture of a project, we can just go through a quick start or quick setups to actually gain more hands-on grasp of this tool. Okay, so I have GCC installed. I have CMake. I have this as well. Okay, I don't have Kafka and console, so basically we need for erasure encoding. Okay, so uh, uh, so erasure encoding is basically optional. Okay, so we can just see it later. We need it. Okay, this is a standalone setup. Let's go through it a bit first. So we are just cloning the GitHub repository. Let me also open a GitHub repository as well. Uh, okay. So it has a shell script for a simple setup of CubeFS. So basically, okay, got it. I thought it was a kind cluster setup. So basically, yeah. So since it is a file system, so it can be started on your local system as well, as a different file system that is already present on Ubuntu. Okay, need root permission. Okay, able to use if config, memory of 4G or more, 4G gigabytes or more, or remaining space is more than 20 gigabytes. Okay. It has a Docker installation as well. What is a cluster mode? Oh, they haven't mentioned what is cluster mode actually. Okay, I guess the cluster mode is for like multi-replica setup. Hmm, deploy.sh. I just want to go through a bit with this bash file so that I can know what there is a difference between cluster setup and standalone setup. Uh, okay, so basically it is starting data service, metadata service, and master service, and yeah, object, deploy client. Let's try it for once. Okay, let's clone this repository. It's gonna take some time. Okay, till then, let's just go through the cluster mode as well. Okay, so basically in cluster mode we also have to make these files as well, since it does not exist in our local subsystem. And after that, we will need to run the script uh, after running the make build command on CubeFS repository. And similarly for metadata node and for data node. Oh, for data node, it is actually making. Uh, it is first actually checking if Uh, uh, Basically, it doesn't has a required file system or not. If not, it will just make a file system. So MKFS makes a file system of the format XFS. Uh, um, I don't know if I have this directory or not. I hope I don't, because if I run this command and I have this directory, all my data inside the directory will be formatted. So we are making the directory data node 0. Okay. Okay, so it is using disk as data node 0, and we are mounting data node 0 on r/dev/sdx, and we are just starting this data node service. This is object gateway. We do not need it as of now, since uh, we are just following a local setup and not on any AWS or uh, any cloud provider. So we don't need S3 or HDFS interface. Optional section. If you need to use the data migration, no, we don't need that. Okay, so this is about it. Okay, let's run. Can we like run all of the command at once? Okay, I will need to give execute permissions to these scripts as well. Okay. Why is the error rising? Okay. Okay, let's try. That isn't working. Okay, we have a Docker installation as well. In this Docker directory, in the Docker directory, run docker.sh tool is used to facilitate running CubeFS Docker Compose trial cluster, including master metadata, data node, and object node. Okay, execute the following command to create minimal CubeFS cluster slash data directory root directory and requires at least 10 gigabytes of free space. Okay, let's just try to run it. We have a Docker repository here as well, right? Yeah, you have a Docker repository. Solution to the following error: delete directory and re-execute command you can specify. Okay, if there is a mount pointer into the directory cannot be deleted. Let's jump into quick use. Till then it is downloading. Okay, so we have creating a volume. Okay, so when we basically build it, it also has a binary for CFS CLI volume, and for that, but our build is failing for some reason. Let's see if we can do it via Docker installation. CFS CLI reads config file. Okay, CSI CFS CLI.json example CLI.json. Okay, these are master node all the IPs for master node. There are 3 deployed, so it must be a cluster mode setup. So volume create. Okay, you can create a volume by this, and note that for all name and owner must match. Okay, so there is a client config as well. So in that we need to provide a master address, owner, volume name, mount point, log level info, and port. And then we, like in the cluster mode setup, we just start the CFS client and specify the directory where our config is stored. Okay, after starting the client, we can actually see the file system that is mounted. Start this here. Its documentation is a bit weird. It should have been on top. This section should have been on the top. Okay, it is building. It has pulled all the images successfully. Okay, we have a Docker environment, CLI setup as well. It's gonna take a lot of time. Okay, let's for that till then let's just go over production next sections. Production environment deployment recommendation. Okay, file system XFS should be there. AXT4, BTRFS, TMPFS. Okay, should be capacity planning. Okay, that's none of our concern as of now. Multi-data center deployment. Okay, these are just deployment tactics. VM deployment is not of our use since we are not using CentOS and uh, any uh, any other distro of Linux. So this is the basic architecture. We deployed it on Kubernetes. Okay, so deploying it on Kubernetes, we need to label the node with these labels, all of these labels, component master, component metadata, component data node, component object node. Okay, and then we are again mounting the data node on it. We can also use help. Wait a second, why we are doing it on a local machine since we are installing it on Kubernetes cluster, then why are we actually doing it on our local machine again? Perform operations of mounting the data disk on the node marked as. Okay, got it. Okay. We can actually skip it as of for now. If we just want to test it out, how to actually set it, yeah, just set it up running on a Kine cluster. So it has an Helm installation as well. So we can just uh, change it to CubeFS Helm, and we need to actually make a configuration file for that as well. So as for the configuration file, it has provisioner and disk that we are using, data node, metadata node, and object node, all of those things. Okay, and then we are just using helm create command to actually apply these all of this configuration. There must be some other setup as well. Let me just search it out. Yeah, this looks a bit better than the other one. What was that? Why is this section under this? This should have been above. Because if someone is trying for the first time, he or she or anyone would be confused. Okay, these both are better. Port already find it. Let's just try to kill the process that is running on our designated port 80, right? The port 80. What? Why isn't it working? Auth tool. What is auth tool? Is there something related to auth tool? Operation, test and evaluation. Okay, these are all the first testing, whether it is performance simulation and features, cache acceleration. So there is a lot of things that are going around this project since it is a graduated project. So I would highly recommend you all to actually try it out or by yourself, whether it is subsystem, multiple replica subsystem. Okay. Okay. So it has an authentication feature as well, or auth node. Okay. It uses Kerberos. Uh, sorry for my pronunciation. Uh, Kerberos. Okay. Ticket-based authentication. Okay. Credential request F1. Object gateway. All of these are designed individual design component design that internally uses. Why is it failing if I'm not running anything on port 80? Okay, so there is a Docker container that is already using it. Okay, Rancher is export. Rancher is actually using it. Okay. Okay, let's just wait for it now. Okay, so we were just discussing about yeah, resource management subsystem. Okay, basically this is just about how individual components are working internally. So as for the first time, I don't think that will be that much necessary for one to actually know about them. Uh, Features, caching acceleration. If you're developing an application similar to an AI model training and need repetitive read the same batch of data to treat the model, it is highly recommended to use CubeFS cache acceleration within. Okay. Uh, Local cache disk. Okay. Using local cache disk of the compute node as a data block, cache can significantly improve the efficiency of data reading. The read request from the client will first access the data cache area of the local. Okay, so basically, read request first goes to data cache area that improves our reading and writing capability, and on top of that, it provides us with parallel metadata operations as well. If I remember correctly, caching consistency, local cache memory. So these are already known concepts. I believe local cache memory, distributed cache, caching on hybrid cloud node. Okay, there's QoS management as well, master interface throttling. The thing I'm most interested currently in is environment, the test and feature, because this is the thing that actually determines why CubeFS is so much widely regarded in cloud native industry and why it is suitable for AI/ML workloads. So yeah, okay, good. Our Docker setup is up, and let's just try it. We have deployed a standalone setup, and okay, so we are. If there is a mountain, if we okay, there is a mountain. Let's go to Grafana dashboard. It has also, yeah, it has also downloaded and set it up the Grafana dashboard for us. So add the username and password are admin and 123456. Okay. This is basic setup. Okay. Got it. So use the following commands to run step by step. Okay, it's just a step by step installation of what all we did. For more commands, prefer this. Erasure encoding. So we are not currently using any encoding system. Okay, so we can just jump into the CLI. Okay, let's start. Is the CLI here? I don't think that CLI is actually here. You have to make a client config as well. Okay. Let's just make a client config. Blob store, build binary. I don't have this directory locally. Start the command line with the default configuration. Is it already the top storage? Yeah. Oh, it is. Is it all? It is already there. Okay. Cool. CLI has been started. Verification. Let's test it. Connection refused. Why the connection is refused? The logic mechanism is not that well here. All of the things are active. Then why isn't it working with this? follows 9500. Okay. And we have a master node on. One 17010. Let's just try it again and see if it works or not. Oh, I need to run it inside here. Okay. No. Then why is it mentioned here that this file needs to be run? Yeah. Okay. Okay, let's just leave it and let's try to explore it on K8s itself. Fortunately I have a kind list to set it up, as you can see. Yeah. Let's make it quick. We had this page around setting up the Kubernetes CubeFS on a kind cluster. Okay, so you will just change it to CubeFS helm. Oh, it's a different. It's a different Git repository. I thought it's the same. It has a different Git repository for Helm. Yeah, that's great. Okay, we are just specifying all of these things. Hopefully this works. Let's try to make it as quick as possible.
You've got 1 minute.
Okay.
Let's see if we can get it.
Okay. I just reached to the Kubernetes deployment, so that's fine. Okay. So let's just close it actually.
Yeah. So thanks everyone for coming. We'll see everyone next week, and give us the closing word, and then we'll close it out.
Yeah, I would encourage everyone to actually try it out on your client cluster and on your local machine. Uh, like I said, I was successful in building it for our Docker image and setting
Yeah.
up for Docker, but I wasn't able to uh, do it for our local machine. So there was some error regarding that. So I would highly encourage if people can figure it out and provide some feedback around this, or
Yeah.
is there anything like wrong with build setup or my local
Yeah.
setup, or I would highly encourage people to actually contribute to CubeFS uh, and specifically to docs actually. Uh, the docs are kind of messed up. So yeah, yeah, docs
Well,
are,
that's why we do it. When you had to get in there and build it, it's like it's going to be one of those days, and that's like kind of what we want to see on the show. Anyway.
yeah, actually
All right.
the docs are actually kind of messed up. So I would highly encourage someone to actually contribute to the docs. I
Yeah.
can understand since most of the folks and the maintainers of the project are Mandarin speaking. So
Yeah.
so it's kind of maybe kind of difficult, for them to do, translate
Yeah.
everything to English. So I would highly encourage some people to actually improve the documentation and uh,
Yeah.
actually make it in a structured format. Like I said, different sections were at places, like they were scattered. So
Yeah.
yeah, and
All right. And with that, thank you very much, and we'll see everyone next week.